Okay, I was playing Repo for a sec, but the fucking solo gnomes are just retarded. Dude, 2 to 4, and I just had like 3 groups of 10. Not, oh god, alright, that's just stupid. I don't know why they changed that. Excuse me. Alright, so now we're doing how to use names. What was it? How to use what? How to use namespaces. Okay, alright. This is just like a summary, it sounds like. Okay. Not originally designed. Yep, it's a mechanism for preventing name collisions. Cool, it lives under there. Okay. Small applications developed for your own use do not need to be placed in namespaces. Larger personal projects that include lots of third-party libraries, though. Well, let's see. Meaning, or especially with other people too, you have your own namespace for your own shit, just in case someone else, you have to call your shit within another function. It makes sense that you would use it in a namespace. Like if you have to, let's see, people define some shit, some kind of like health for, well, I mean, really you get past namespaces by just using good unique identifiers, but larger projects with a lot of third-party libraries makes sense because you don't know what they call things. Namespacing your code prevents collisions. Okay, makes sense. Yeah. Meaning when you include it and everything's just in global scope or in, yeah, global scope. It's not within its own namespace. It's in the global namespace. Okay. Oh, distributed to others should be namespaced. Often a single top-level namespace will suffice. Footlocker. Oh, true, yeah. If you place it, they can do it and then see all the shit inside it with their ID. Yep. Yep. Two level or three level. Meaning that they put different, they work within similar namespaces. Okay, so there's a whole library. Oh, hold on. No, this, meaning that two or three level namespaces. Oh, okay, I got you. So the library within this namespace that they all work under, they have their own separate project or library within it. Or they have, oh, okay, Fusa Logger. Oh, I see. So it's project or library, and then the module, so the piece, just like the chapter from a book, company or org, and then a subsection of it. Company or org, project library, and then piece within that. So you could have a project or library within a subsection. But then you could have things that have multiple libraries. Therefore, you could have things with multiple libraries, and the libraries themselves have their own little subsections. So that makes sense, yeah. So like you have your character in namespace, and then within the character namespace, I don't know exactly how this will work for classes because I think this works. The scope resolution operator works for classes too, but you could have a namespace to define. It's just the higher level shit. So the highest level stuff would be there's food, and then there might be a fruit namespace because fruits have their own different types of nutrients. They all include different types of nutrients. They all include. I'm slurring because I'm tired. They all have whatever these vitamins, or they're all made. They all have fucking a cell wall in their cells, and then within that you have the subtypes of whatever, the different ones, the different onions, and the onions have onioning functions that aren't used by others. So separate your functions out this way. If you go to your character, it shouldn't instantly be, or you go to food and it shouldn't instantly be the onion functioning or make player cry. It should instead be food, then vegetables, then onion, and then make player cry. Something like that. Cool. Can help separate code that might be reusable later. Oh, okay. So two different namespaces. So you might have like one namespace that's this chapter that's like that's combat, or like something that governs a couple cutscenes, and you might have a different namespace for each cutscene because in each cutscene, maybe you have a different namespace for each, and in your cutscene 1 or cutscene 2, whatever, however you name them. So you could be like intro cutscene, and in that you have a variable called time start, and then this, and then that, and then another one where it's this, and then that. And each one has their own thing. It sounds like you put functions in there, though. It sounds like you don't do variables within these namespaces. I haven't tested that yet, but it seemed like we were doing multiple definitions and shit. Okay. This is good. Today I'm at a low brain power day because of the sleep last night, so I'm gonna get to sleep early tonight. I'm gonna do 11:30. That'll be my time. So 12's too much. Well, really, last night it was 1, so it was way too far. I pushed it. So I went from 7.5 hours of sleep to fucking 6, or 7.5 or less to 6 or less, and that ends up being 5 something. But if I get in bed at like 7:30 and I get like 7 hours of sleep, then I'm chilling. If I go and get in bed 8 hours before, then I'll wake up too early maybe. So if I end up waking up at the same time anyways, then that means I need to go to bed at the same time and then just wake up and then do something in the morning. So tomorrow morning I might record if I wake up early. Depends though. If it's like 30 minutes, that's not enough. Because I like feeling good when I'm sitting and recording. I don't want to get straight I really don't want to get out of bed and go straight to this. But I could shower early, I guess. Okay. I guess I should respond probably. Yeah, physics and math could go there. Language and localization could go into lang. Oh, let's see. Module level namespaces. Okay, namespaces. So we could have. So these are all still talking about functions. Directory structures. Should avoid deeply nested, so no more than 3. Okay. Unnamed namespaces and inline. Oh shit, inline. Here we go. Learn about inline functions and variables, maybe. And all of these were all only talking about the parameters. We were only ever using parameters. We were never using identifiers of identified. We were never using variables that were defined, or I guess what do we say? Yeah, that were defined in these namespaces. It was always just using a function and its parameters. All right, let's see what people are yapping about. Your basic math, add 4. Okay, why would you do 4 comma 3 instead of 4 comma space 3? Here's wrong. Name followed by that must be a class or namespace name. Well, yeah, it sounds like a fucking IntelliSense issue, buddy. Historically they haven't. Now it is. Damn, Alex didn't even upvote your shit. Holy. Every time we add functions to Goo, do we have to what? Hold on. When Goo is nested in foo, when we add it, we have to type out foo goo? Or just, well, we can't just get Goo, bruh. Because there's no Goo in global scope. So every time you type something, you type in X, you're getting it from the scope that it's within, that it's aware of. And functions that are declared within global scope. So main is within global scope. There's this global scope, and main is one of the functions, and that's where the program starts and finishes. Okay? So, or at least I guess main is the main shit that's run. Technically the stuff before gets run before. Well, no, it's just defined. It's not actually run, because we could have a function before main. It's not actually run and return anything until we call it. We have to call the function. But main doesn't need to be called. So main just happens. And in main, which is in main, is within global scope. So all it knows is global scope. If we made more shit in main, like like an if statement, a code block, right within main, it wouldn't be aware of any of that shit. So main is only aware of global stuff. So if foo is within global scope, it's this other namespace that's in global scope, and then goo is within it, main can only get stuff at global scope. Well, what's in global scope? Foo is in global scope, but goo is not. So if we have global scope, main is a little guy, and he sees all the stuff that he's a part of. Just like a just like an ornament on a branch of a Christmas tree. It is aware of the branch that it's on. Or let me see. That doesn't make sense. How about the branches? There's a branch on a Christmas tree, and it has its own shit. It has its own ornaments, and it can do stuff with its own ornaments. And then there's the trunk of the Christmas tree. The branch is aware of the Christmas tree trunk because it's from the Christmas tree trunk. It's also aware of these other branches because it can see them. It's right next to there. But it isn't able to see all the little shit that each of those branches has. It just knows that there are other branches. So in order to tell this branch to use the ornament from this branch, we have to say, okay, so global scope, the trunk's branch, which we can say just branch because it's already within global scope, the namespace. This branch's ornament. So this namespace's namespace. We can't just talk about the ornament. So like in this case, he's talking about adding functions to Goo. So adding a color to an ornament that is on a branch. We can see this branch because it's part of the global scope. This guy's part of the global scope. This guy's part of the global scope. They're both aware of each other because they're both within the same scope. Cool. But they aren't aware of what's in each other. This branch is not aware of this branch's ornaments. So we have to say, get this branch's ornaments. So if we want to know that this color's, we want to print the color of this branch's ornaments, we have to say, okay, this branch, foo. This branch's ornament. So foo's goo, the branch's ornament, foo, the foo namespace within global scope, and the goo namespace within foo's scope, and then goo has a function. So we have to say foo goo, boom. Or, let's see. Or just namespace goo. And if both ways work, well, it's not both ways, buddy. You can't just say goo. You have to go and find goo within foo. So put one or more functions inside namespace foo, which has namespace goo within it. So if we want to add stuff to goo, okay, this guy, he responded kind of wonky. He wants to add stuff to goo, which means we have to go inside foo and put stuff inside goo. Or you can put stuff inside foo goo. Because foo goo is goo, because goo's in foo. Just like foo goo is goo. If you put shit within this guy, you're putting it in goo. But you have to get this goo by going to where foo has goo. Or you can say foo has goo, we know this. Boom, we can put it here, somewhere else. I'd use the first when foo has other shit, and second when it doesn't. So if we're doing other stuff, I'd use the first when foo has other things you're declaring at that point. So if we're putting a bunch of stuff in goo, let's go and just put it in the main part of foo. But if we're only putting this extra like little piece, then let's just put it in foo goo wherever. Some extra stuff. The problem with that is you're gonna have to include, if these are in header files, they are probably in header files. You're gonna have to include this other header file to figure out where you put other shit. So probably keep most of your shit here, and then have different chapters. So like one big ass piece of goo. So once it's really fucking maxed out, then you can have another one where you might include some stuff for foo goo. Or like you have the combat system and this other thing, and they're both in goo, but you have part of goo in here and part of goo in here. So you have like the health system from goo here, or the health system from your character namespace here, but then you have the combat system from your namespace here, or like the movement from your game namespace here. Different spots. So when I include one, I get all the shit. I don't have to include this and include this to get two pieces that are related to each other. Just like I can use string view and we're totally cool. But I have to include this extra thing called string, and I have to include this extra thing called string view if I want to do this other stuff. But I'm totally good to do string and a whole bunch of different stuff with just string. If I say namespace goo and then some functions, is it different from namespace foo goo? Well, yeah, because it's inside foo, bro. Oh, hold on. If it's nested directly inside foo, otherwise, yes. Hold on. Yeah. Yeah, because if you put inside foo, foo has its own namespace called goo, but then inside global scope, you have this other one called goo. These are two different namespaces because they're within two different scopes. Just like you could have that tree and you have branch, and you have one branch named goo, but then you have another branch named foo, and he has an ornament named goo. This branch is foo or goo. This branch is goo. They're two different goos, bro. Yeah, I don't know what this guy's talking about. He's talking about a bunch of crazy shit. It's a global variable with type standard output stream. Oh shit. And then just like standard character error. An abstract wrap. What? An abstract class? Yeah, I don't know what he's talking about. Static member functions? Oh, good god. Oh my god, it's later. Okay. Oops. So next up. Local variables. Holy. Oh! My eyeballs. Okay. We introduced local variables defined inside a function, including function parameters. Doesn't have a single attribute that defines variables being local. Instead, they have several different properties that differentiate how they behave from other kinds of non-local variables. Okay. Scope. Where it can be accessed. Yeah. So if we have foo has its own scope. That identifier has a scope. The foo identifier has a scope. And it has namespace goo within it. Goo can only be accessed within foo's scope. So if we make another goo within global scope, not foo's scope, that goo in global scope and that goo in foo's scope, those are totally different identifiers because they're within different scopes, so they're unique. Excuse me. So if I was in foo and I wanted to use the global scope goo, then I would say that. Otherwise, it would already use the one that's in the global scope's goo, and I want to use the local one. I just use goo because it's already within its scope. But if we didn't have goo, then it would use the goo that's global. But because we already have one in there, we need to use the one that's outside of them. So we just do scope operator before to get the global one explicitly. This is very cool stuff. I love learning about scope and variables and namespaces. This is super fun. When it can be accessed, it's in scope. Okay, yeah, it would be, so goo would be out, well, yeah, goo would be out of scope if I try to use it with it. Like, if we had two namespaces and each one has its own thing, this one is out of this guy's scope, this one is out of this guy's scope. This one is in his scope, this one is in his scope. This one is in his scope because it's within global scope, and this guy is technically within global scope, so. Oh, my Steam on. Do repo feedback real quick. Nope. I'm gonna write a little thing. If it can't be accessed, it's out of scope. Scope is compile time, and trying to use an identifier when it is out of scope will result in a compile error. Cool. Just learn the language, buddy. Local variables have block scope, meaning that they're in scope from their point of definition to the end of the block they're defined within, and the block being the opening to the closing brace. So we say I enter scope upon definition. And variables are defined upon declaration. We're talking about variables here too, so okay. Yep, that one enters here because this one's defined here. This returns, and then the function ends, which is when the scope ends. It's the end of the block. On the wrong block, buddy. So they could technically enter scope before the opening curly brace. So these guys, these are the parameters. The values are copied from wherever max is called. Here. These values are passed here, so these guys are created, instantiated, initialized, defined. Boom. Enter scope here. We're then saying there's an integer called max here, which is weird because you're saying max. I don't know. I'm not a big fan, but you're now initializing this guy. So you enter scope here, value initializing it, or sorry, list initializing him as being if x is greater than y, then he's x. If it's not, then it's y. So we just return them bigger. We pass them two ints. We return which one's bigger. But there's also a bug here because if he's not greater than, it's gonna return y, even if they're equal. So if you pass them 2 and 2, it's gonna return y2, not the x2. But, I mean, I guess it's the max in both, so it doesn't really matter. And they all leave scope here. So they're all destroyed because it's the end of a function. It's the end of the block. Gotta step off the block. All variable names within a scope must be unique. Well, yeah, because we already have a parameter named x here, and we have another variable named x here. Both of these are local variables. They're both within some function's scope. So, compilation error. Multi-definition, bucko. He's already been initialized. Can't initialize him again, buddy. Yeah. We had like void do thing and x and x name. Boom. No, sir. You have redefined him. Yep. Same block scope, same name. Womp womp. Automatic storage duration determines a variable storage duration determines what rules govern when and how it will be created, instantiated, and destroyed. In most cases, it's defined by its or it's determined by its lifetime, and we describe lifetime there. So the lifetime is the time from which it's created to its destruction. So it's the time that it's accessible, basically. Once the function's gone, can't use them anymore. Local variables have automatic storage duration, where they're created at the point of definition, destroyed at the end of the block they're defined in. So I is defined and is defined and created and instantiated and initialized on 3. Same thing with D on 4, but then they're both gone on 7 because that's the end of the block, bucko. That's automatic storage duration. They're sometimes called automatic variables, as not to be the same as type inferred or auto variables. Auto inference. Local variables in nested blocks. They can be because they're in their own scope. So we could have x in main and then y within a block, and we could call it a different thing. Yep. So we could say there's an outer block with an x who's initialized in there. We have this nested block. Y is initialized created there, but then it's immediately destroyed right after the next line. So not immediately, but next line it's destroyed. Y can't be used because motherfucker's been destroyed. It's out of scope. He's not in scope. And then it returns 0, and then after we destroy x. Yep. Y is defined in a nested block. Its scope is limited from its definition to the end, which is literally 1 line, or technically 2 lines if you did it. Used him here and then had that end brace be, or the closed brace be at the end. Its scope is limited from the point of definition to the end of the nested block, and its lifetime is the same because it's an automatic variable. It has an automatic storage duration. Because the scope is limited to the inner block in which it's defined, it's not accessible anywhere in the outer block. Note that nested blocks are considered part of the scope of the outer block. They are part of the scope of the outer block. Wouldn't you say the outer block is part of the scope on the inner block? So variables defined in the outer block. So if we have an inner block and an outer block, stuff defined here can be used in here, but stuff here can't be used outside of out here. Why? Because if we have this inner block and we're running stuff, this is outside of this block. Well, I mean, I guess it's in the block, but it's not really. The block is really from like here to here. Okay. Variables defined in the outer block can be seen inside the nested block. Okay, time to go.